All right, hello everyone, welcome. Hopefully this is all going to be smooth. I haven't had any streaming issues before. I don't know why I did now. Just let me know if you can't hear properly or if the music's too loud or I don't know, whatever. Um, and then we'll go through it. Yeah, and feel free at any point along the way to just drop a message in the chat. I have it open here on my other monitor so I can see if you type something, and I can address any questions or whatever you have. Okay, let me just close some stuff down. All right, just ping a message in the live chat to let me know that you can hear me, and then, after that, I'll start. Awesome. Good stuff. Okay, so, I'm here in my garage with my Lamborghinis, but you know what's better than Lamborghinis? Git and GitHub. Basically, the thing is, I know that Lyle kind of threw you into this whole Git and GitHub stuff, but it's something that I've worked with for quite a long time in pretty much all of my IT jobs. But it's just pretty much industry standard, and it will be useful for you if you do anything coding related, but also kind of just enforces like best practice and kind of, I don't know, keeping an eye on what you're doing with your code and just doing things incrementally. So I think in general, it's a good way to approach coding, and the workflow is quite nice because it just encourages you to do small chunks of work and save it. And that way, if you go back, if you've changed something and you're like, oh shit, I don't know, whatever, the thing was working on is broken, you can kind of pull the information back from time, or at the very least go on GitHub and just see the entire history of what you've been doing. So in that way, it's super useful. And I want to say, just don't panic. Like, this has got nothing to do with the exams or anything like that. But considering Lal wants us to do it this way, I think I understand why. I think he's trying to like give you some new methods to do things, and I think it is very useful. Like I say, if you do anything tangentially related to coding, you're going to be using Git and GitHub. And even later on, especially when you're doing things with R or whatever, even if you don't want to do coding, if you want to do some data analysis, there are going to be situations where you're going to have to deal with Git and GitHub. So this is going to be like a super kind of brief overview, bare basics, and just to get you started. And I think the idea is to focus mainly on GitHub. You need to know a few Git commands, but GitHub's going to be the kind of main thing because it's sort of easy to work with, and there's like, the web pages you can navigate and whatever. All right, so let's see. Oh yeah, close my slideshow window. That was great. So it can seem a bit overwhelming at first, like there's a lot to deal with, but in reality it's not that complicated. Of course it can be if you get into like all the nitty-gritty details, but like at the level we're working, it's pretty straightforward once you get a hold of the basics. It may not seem that way right now, but I promise it will become clear, and hopefully I can do something towards explaining that. Yeah, so why use Git and GitHub? Well, yeah, you always have a history of changes and stuff you've made, which is obviously useful. And this goes beyond, like, for example, storing your stuff in OneDrive, which has like an archive history. This is, every time you make a change that is important, or even a small one, you make a commit, and then you can push it straight away to GitHub, or you can just leave it on your local computer for a while and then push it later. But yeah, it makes that easy, and then you don't have any issues with like a file having changed twice and then code getting like overwritten and whatever. And easy collaboration and easy sharing, they're kind of both related, but the collaborative part is that with GitHub, it is pretty smart in dealing with like multiple people working on the same code. So obviously it's not live collaboration, like you don't see someone typing and then the changes immediately. But what it does do, for example, if we're both working on the RMD for the portfolio, and I change the answer to exercise 1.1 and someone else works on exercise 3.2, and we both make those changes and we commit it and push it, well, GitHub will say, and Git will say, well, there's been changes, you can't push this, just pull them down. And it does a really smart way of merging it. It knows that person A has worked on exercise 1 and person B has worked on exercise 3, and it brings that together. And if in the cases where it fails, it does offer you a solution to say, all right, I want to pick this one from this person and this one from that person. But it just makes it a lot easier. And then that way you don't have some crazy mess where it's like, I change something and then I lose everything else that everyone's been working on. And the same thing with sharing. That's why it's GitHub, because you post it on the internet and it's open source and everyone can see your code and they can submit patches and say, hey, look, this part of it's shit. I suggest doing it this way. And that way people that have like smaller projects or even really large ones can get a lot of people involved in collaborating and just, making the whole thing better. So this Git software was made by Linus, but, not our Linus, the Linus Torvalds, the guy that made Linux. And he really didn't like, he's an interesting character if you ever have time to research him, but he really didn't like the SCM, like source code management. So he made this system, Git distributed, which means everybody has a copy of the repository and everyone can make changes. And it's not like every time you make a change, everyone gets angry because then all their other things are broken. So, it's an awesome solution. He put a lot of thought into it and he's a fucking crazy smart guy with a attitude problem. So there's multiple options to tackle this. You can use GUI or console. I advise, as Lau did as well, to use the terminal or whatever to work with it mainly, because it's really not that complicated. There's just a few commands you have to remember. And as in R, you can always ask for help with the commands. But if that's really not your thing and you hate the idea of using the terminal, there's pretty decent options. Like on the right of the screen, we have GitHub Desktop, it's called, which is like the official one from GitHub themselves. And it's a pretty simple GUI. The thing is, even using these GUIs, you still have to understand the basic commands of Git, which is why this will be useful no matter which option you choose. Because if it says something like push or pull or fetch or merge, you have to kind of know what that means. And the second one is Git Kraken, which I've used in the past, and that's quite nice. It's a pretty good interface and whatever. And, as you can see, you get like visual timeline of the changes people have made and stuff. That, of course, is more interesting on bigger projects or projects that you're working with more than one person. So either one will work for your own stuff, no problems. But all the visual stuff, it's more important for when you're on a bigger project. And as well, you can use the integrations with your IDE. I actually use the one in VS Code quite a lot because it makes it pretty straightforward. It's the same thing as writing the commands in the terminal, but I already have it open in my window. So I just say like, add these to my latest changes and then commit and push it to GitHub. So I would recommend giving that a go as well. You can add in RStudio your Git repositories and that kind of thing. So this is the main important stuff that we're going to go through. Creating a repository, cloning a repository, forking a repository, pulling code, committing code, pushing code, branching, and merging. So I'll just go through these briefly, one by one. Creating a repository, that seems pretty self-explanatory. You just create a new Git repository. I'm going to show you how to do it on GitHub and then bring it locally, because right now there's no need to worry about the initializing a repository on your computer and stuff. And then cloning is what you'll do after you create the repository. You make a copy of it on your machine, and then you have your version of the entire Git and whatever code you've put in there. Forking repositories, that's what we've probably all done with Lau's repository. that essentially just says, hey, I'm going to branch off from the code that I'm forking and make my own changes to it, and then I'm going to manage my own version of it. I mean, people fork code for many reasons. I got forks of tons of public repositories because I want a particular version, or I've had to make a patch. Like, I don't know. One thing I made was on my Discord. I've got like a music playing bot, and that's hosted on my Raspberry Pi that's sitting in the living room out there. And there was major issues with the code that didn't want to run on Raspberry Pi, so I made my own patches and forked the repo, and just I'm using my version of it now, which works fine. So that are some of the reasons you might want to fork a repo. But in the case of the studies, we're doing it so we can all make our own solutions, and not have to like deal with everyone committing the same stuff. And plus, Lao's repo isn't public for that anyone can write to it, which of course is standard practice. But if you have it on your own GitHub, then you can push the changes to GitHub and you'll be able to like use them from anywhere. Pulling code, that's just like getting the latest stuff. If you see in this little graphic here, it gives you the kind of basic workflow on both of these. And it's like pull or rebase. Rebase is just a fancy way of rerunning the history of each commit that you've made. And then it will go through and add all the stuff that you pull, so changes from GitHub or changes from Lao's repository, whatever, and then it will update them on your local version. And then committing code, obviously that's what you're going to be doing a lot of when you make changes. You commit the code, and you can make as many commits as you want without pushing it. It just basically adds a little tag along the way to say, this is where we're at now. And then finally you push the code to GitHub or an upstream repository. In our case, it's going to be always GitHub. And branching and merging, this is slightly more advanced, but I think it's worth mentioning because it's just a nice way to work. Like, if you're always doing everything in one main branch, by default now the Git branch is called main. If you do everything in there, like if you make specific things for, okay, a good example is what I did with the Practical 2. I created a new branch for that and just started making all my stuff in there. You can still bring in the changes from Lao into the main branch and into your new branch that you've created. And it doesn't make a whole lot of extra space on your computer or anything like that, but it just allows you like a separate space to work on a specific feature or a specific assignment or whatever. And when you're really happy with that, then you can what's called merge back into the main branch, or you can leave it in that branch and work on something else in another branch. It just gives you a bit of flexibility, and yeah, generally it's a good way to work. This kind of graphic here just gives you a little bit of an overview of like what forking and whatever does. So you have like the GitHub, and then you make a fork of it, and then you work on it on your own and push your changes to that. And then you can pull the upstream, which is what we've all been doing when Lau's added new stuff. We've pulled his changes into there. But I want to show you how to do that on GitHub as well, because that process of adding upstreams and whatever to your local thing, it's a bit of a pain. Yeah, exactly. So it's going to be a lot, but hopefully, it should be, by the end of this, will be a bit more clear. And as I said, if there's any questions or something, just dump them in chat and we can go through them. So unfortunately, it's designed to be a secure way to do things. You don't want some rando like pushing code to your stuff and saying, pretending it's you. So to do that, the easiest way in Git and GitHub is to use what's called SSH, which is a pretty standard thing across any computer. Like if you're on Mac, you'll already have it. If you're on Linux, you have it. And if you're on Windows, you may already have it. I've just put in some stuff here in case you're on Windows and you don't have it. And I'll just run through now the terminal commands to just get you started. So you need to do this. It's kind of like a prerequisite for pushing your code back to Git from your local computer. So let's see. I'll open up a thing as administrator. So this is the first command on Windows in PowerShell. You can just say like which versions are available. You only need open SSH client, and I've written the command in here, which is this add Windows capability, blah, blah, blah. You can copy and paste it. I can put the slide somewhere, or you can just type it in from the stream or the video. Once you've got that, then you have kind of the prerequisites available. And then after that, I'm going to show you on Linux, or also this will work on Mac. This will also work on Windows. But because I haven't set up a SSH key in my Windows, in my Linux environment yet, I'll do it here. That way I'm not overriding mine and fuck up all my stuff. So we just do SSH keygen. So B4096, so this is saying you want a key of 4096 bits, which is pretty much the standard now for security. It's hard to hack. It'll take years and years and years with a supercomputer. And the type RSA, that's just the algorithm it uses. Don't worry too much about it. This is going to be all you need, is security enough. So it just automatically generates a private key and a public key. The private key, no one else except you knows, and you don't have to care what it is. It just stays saved somewhere. And the public key is the one we need to add to GitHub. So I'm going to do this now. And it says this is where it wants to create it. That's fine for me. Generally, it's in your home folder in Windows. That will be like, C users, your username, and then .sh. That's where almost all the software that uses SSH looks for your key. And in OS X or in Linux, it'll be home, ZS for my username, and then .sh, blah, blah, blah. You don't want a password. You don't need it. If you want to, you can, but it'll ask you every time you try and commit code. I have that, but it's not necessary because I use my SSH for a lot of other stuff, not just GitHub. So you can press enter for no password. Then it just gives you some like random input, which uses to generate the key. So it's like unique to you and secure and whatever. So that's it. That's all there is to the SSH thing. But there is one thing you need to do, is get your public key. So it tells you where this is here. Your public key has been saved in wherever. So I'm just going to show you what it looks like. This is not a security issue. Anyone can know your public key, and that's fine. They still don't have access to your private key. So in Windows, you would use the type command, type. Cat may work in PowerShell. Otherwise, in Mac and Linux, you use the cat command, which just like prints out the contents of a file. So cat, and then I want to use the new public key, .pub is the important part. And then I press enter. So this is the RSA key. So this is all done. All I need to do is copy this and add it to GitHub. And then from now on, don't have to think about it again. So I know this is kind of like a bit involved or whatever, but you really don't have to worry about it too much after doing this. What you're doing is providing a way for GitHub to know that it's actually you when you commit code. That's all. So let's go to GitHub. And what you do is go to your settings. Yeah. And then SSH and GPG keys. You can see I have some from my laptop, my home computer, and from the Raspberry Pi. So these are the 3 places where I've worked on code. So I add a new one. You can call it whatever you like. I'm going to call this like so then I paste it in here and add. Got to confirm my password. So now this is the new key. You can delete them at any time. That's fine. Or create new ones, add new ones, whatever. So now this is set to Git. If I want to, no, the SSH key is not connected to a specific device. You could use the same key, but it's bad practice. So for example, where I created this one, it's only this public key, which is in my Ubuntu Linux virtual machine. So it's nothing to do with IP address or anything like that. It's just the computer that you're working on. You could copy and paste that public and private SSH key to another computer and use the same one, but don't do that. This is like a 2-minute job. It's not worth it. And it's much more secure if you have an individual key. So when I commit code from this computer, I can find a record and see that, okay, this code was committed from my desktop or my laptop or whatever. So yeah, it's essentially device connected, but you could reuse them. but nothing to do with IP, so you can take your laptop anywhere and commit code with it. Yep, so now that that's done, I think we should get on to the actual important part. Oh, that's not my presentation. Yeah, so I put the link in the slides as well to get to the key thing, but I showed you as well how to navigate there. So let's do this on GitHub. We'll create a repo, clone the repo, do some shit, and commit it. Pretty straightforward. So let's get started. So if you go to your GitHub page, home, whatever, you can just create a new repository, and I'm going to call this one GitHub demo. I mean, we could call it Cuddly Spork, but whatever. Just a test for the live stream. I want to make it public. You can even do stuff with my repository if you want to see how collaboration works. I have no issue with that. I'm going to delete it afterwards anyway. So what I suggest is add a README, add a Git Ignore. This has various presets for different languages. So depending on what you're doing, you can say R or Python, for example. So without going into too much detail, what Git Ignore Files do is say, don't ever try and track the things in this file. So if I have like metadata, or if I have like just random shit that I'm typing and I put it in that folder, but I don't ever want it to go to Git or GitHub, you can add it to the Git Ignore and it will just never consider it. It's useful in some cases, and especially if you're working like with a IDE like RStudio or Visual Studio Code or anything else, they generally put some metadata there that you don't want or need to go to GitHub. But otherwise, you don't have to do this. It's just a suggestion. But I would say always put the README, because then it creates a repository with something in it, and it will save you an extra step later. So create the repository. Now we have our brand new repository here with a Git Ignore and a README, nothing else. So this is where we start the cloning process. So we have code. HTTPS will mean that it's a bit of a pain to commit code back to GitHub. So if you use SSH, now that we've set up the key, it's going to be easy as fuck. So we just copy that. Again, like I said, you can use GitHub Desktop and stuff, and then that will maybe be easier if you want to use a GUI. I'm not going to go into that because it should be straightforward, and I really want to demonstrate like the main terminal commands here that you're going to be using. All right. Fuck. Not used to talking so much. Oh. So we have now on my Linux virtual machine the folder here I created already before a Git demo, and I'm going to clone it into here. So I can just say Git Clone. So this is the command that copies your repository from GitHub or anywhere else, but in this case we're always going to be using GitHub, and we're going to clone it and create it into a local folder on your computer. So because I added the SSH key, it doesn't ask for usernames or passwords, but it knows who I am, and it says that's fine. So now we can see there's a GitHub demo folder. I can go into that, and the README file, and of course the hidden .gitignore. I'm going to do the same on Windows. It's no different, but just to make, just to show you, what the fuck? Oh yeah. Okay, so OneDrive, actually no, sorry, I'm, in crazy mode. Projects. GitHub demo. Okay, so same thing, just git clone. Right, it's that simple. I have my SSH key already from my main computer on there, so that's what it's using now. So next step, we'll make a new file and commit it and change it, and I'll show you a few of the stuff. So this is the practical exercise thing. I don't want that anymore. I'm going to open the folder I just created in projects, and then GitHub demo. Right, so we have our README. So adding some new stuff. And then I'll create a new file. I'll just call it ignore me.txt. Super secret stuff. Okay, so I did mention GUIs before. I will just show you what it looks like in Visual Studio Code. It's going to be similar in a lot of stuff. So it says changes. I didn't save this file, so let me save these. So we can see changes to README, which already existed. So, and then ignore me, which is a brand new file. And then in here, I would just add them with the plus sign, and I can put a message for the commit. Otherwise, this is where the real meat of it is. We have the terminal, and it's going to be the same in Linux, Mac, and Windows. There's going to be no difference. We do git status. This is a really useful command that just shows you the list of anything that's been changed. Okay, I'm in the wrong folder. Git status. Oh yeah, okay, that makes sense. There we go. So, this shows me nothing has been staged for commit, which means I haven't added it to this next commit batch or group of code that's changed that I want to put together. Because you don't have to add it all, you can do just one file and leave the rest if you're still working on particular stuff. So it says, yes, I've modified the README file. That's correct. We've done that. And there's an untracked file, which means it's brand new. And it's called ignore me.txt, which is correct. We have these two changes. So to add everything, including all the untracked files and whatever, you can just do git add dot. That basically just says add everything in this folder. Otherwise, you can do it individually and say, I want to add the changes to README to this next commit. Also the ignore me.txt. So you can add multiple files, you can add folders, you can do wildcards, like normal kind of command line stuff. But, or you could just say the whole folder is also fine. So if now we do the git status again, we see that changes to be committed. That means that these two files that we've changed now will be ready in the next commit. So let's do it. We'll say git commit, and then you can add a message, which will be like, added secret stuff. And then because you got to have emoji in your git commits. Not really, it's just this will take a while because I have like a extra security thing which signs my commits. So here we are, that's committed it. So basically now your changes are part of the repository, which you could leave it at this if you want, because you don't even need to use GitHub at all. You could do all of this only locally and never go to GitHub. And then it will still keep all of the tracks, like changes that have been done to your repository, and you can track it all and go back in history and stuff. But you can see I've got like a little notification thing here which says there's one commit that needs to be pushed to GitHub. And this was like, one file added and one file changed kind of thing. So now if I do a git status again, it should show, everything's good to go. Nothing to commit. But it does say my branch, so the local one here, is ahead of the main branch on GitHub, which is, they call it Origin, because Git wasn't designed around GitHub. GitHub came later. So Origin is your main repository that everyone commits to. And that doesn't have to be on another computer. It can just be the one you already have, or in this case, GitHub. So it says it's ahead of Origin main by one commit, which means that if I push, then the changes that are there, that one commit will go to GitHub. So git push. So now it's sent those changes to GitHub, and I can just refresh the GitHub page and we can see an ignore me, the commit message for the files that I added, and the readme, which has now adding some new stuff. So it's really that simple. I mean, it's just a way of like incrementally tracking your changes. I mean, now if I want to add something else, more secret stuff, then same process. I already know it's changed. I'll just go git add. Oh, actually, I'll show you a shortcut as well, because we've already been through the other one. So if you already know that you want to commit everything that you've done, then you can just do git commit -am, which means the -a is all and the m is still the message, but you just have to put that last because you're typing the message afterwards. So, you know, extra stuff. So that in one line did the adding and the committing. Then we can just do a git push again, and then it'll be extra stuff. See the latest commit here. So I'll show you on GitHub what the commit history and everything looks like. So you got 3 commits to this entire repository only, and these are the 3 things that I've done. And if you want to see exactly what changed in these, you can just click in them and you'll say, oh, look, we added more secret stuff. The same thing is available on your local Git, whether you use a GUI or whether you use the command line. You can just do Git Log, and this shows you the stuff that's changed. And if you want more details, you use git show. Git show, and then you can put a commit ID, or yeah, that's probably the easiest. So this shows you what changed. Oh, look, added some new stuff. And then, yeah, Q to get out. It should be the same across platforms as well. All right, so that's those basics, I think. What else? Yeah. So pulling is if someone's made a change to your repo somewhere else and it's not synchronized, you need to bring those changes in. So let's do this. I have just consider these 2 tabs as different computers, because for all intents and purposes, they essentially are. So now if I have a look, it says it's fine. There's nothing there, but we don't have the, you know, secret stuff file, which means that it's out of date. So in this case, we use the git pull. So that will pull changes from GitHub to this repository. But you can be in a situation where you've made changes in 2 places and sometimes things don't work exactly as expected, but we'll just show how that works. If I go touch, which means create a file in Linux-like operating systems, whatever, like another file.txt. So if we do, we can see there's another file here. Oh man, can't type. So let's add that. Okay, yeah, all right, whatever. Yeah, it may ask you to do this. Actually, I'm glad I tried this because it may ask you to do this the first time. So this is going to be your email associated with GitHub. And this is the username you want to use for GitHub. It'll just be what shows up on the commit. It can be anything, but like it makes sense to match your GitHub username. Okay, so now I can run this command again and it's fine. So imagine this situation where 2 people have worked on the files, or you've worked on it on different computers. You want to push this to GitHub, but you're not aware of the changes. You'll see what happens. Git push. Okay, failed to push. I mean, it kind of explains it. Sometimes the language used is a bit kind of confusing, but whatever. That's how things work in IT. So it says updates were rejected because the remote, which in this case is GitHub is the remote, contains work that you do not have locally. Makes sense. We added it from the other place. This is usually caused by another repository pushing to the same ref, all that stuff. Perfect. So what you can do is, again, we git pull, because now we know that there's changes on there, and we pull the changes from GitHub. So git pull, and it should automatically just work. Like, it's saying add a message to what you want to say about the merge. You don't need to do anything with this 99% of the time. I'm just going to exit. You can see it's Control X. For some reason, it's using nano. And that's it. It's pulled the changes. But if we look, it has the ignore me, and it still has another file. Nothing's been deleted. Nothing's been overwritten. And I can now push this because it's merged it already by itself with the git pull command. And if we go to commits, refresh, there's a new merge one. And if we go to the main code here, we'll see another file as well. So now it's just, you know, it's really nice in that way. You don't lose stuff, and it handles it very well. And the same thing applies if you're working on the same file. Sometimes you will get what's called a conflict, and it will ask you to resolve it. But that's going to be probably rare for the situations we're working with. If it happens, seriously feel free to ask me about it, and we can run through it. But it's just wait till you get there. Don't worry about it for now. Yeah, okay, so that's pretty much the main stuff. The branching, as I said, this is a way to like make a separate section of your code based on the main branch, and it just copies it into a new branch, and then you can work on stuff and then bring it in later. So this is where I'm going to show you the pull request sort of process, which allow us for the assignments, but I don't know how much he cares about it, but it's another way of working. So I'm just going to create a test branch. Oh, actually, check it out. So git checkout means change to a new branch or whatever. Oh yeah, okay, upstream, downstream. So to explain that easily, you have upstream repository, which is, if you imagine a hierarchy, you have, okay, I'm just going to stick with using the example of Lau's repo because that's what we've been working with, and I think you'll be able to kind of get that hold of it better. So if you imagine the hierarchy of repositories, you have the source of truth. I mean, it's not the right words, but like, let's keep it in this framework because you might fork and create branches and code for many different reasons. But let's say Lau's repo is the source of truth. It's up here. I make a fork of it in my repo, and that's here, and that's on GitHub. But then I have another thing here on my computer, which is the same repo cloned from my GitHub, and that's on my computer. So I make changes at this level, then I push it to the upstream. The upstream, in my case, so I'm going to call, so like what Git with GitHub is referring to, so we have the origin. So the origin of the code is my GitHub repository, but then I can push to that, or I can push, if we were allowed to, directly to Lau's repo, which is the upstream. So because normally you're not allowed to just push code straight to the upstream, you push it to your GitHub fork or your code base or even just your local one, it doesn't matter. But then you have those levels. So the origin is your main source of truth code, and then the upstream is wherever you got that code from, or wherever you've been like forking off or basing your code on. So the flow with GitHub is you commit your code to your repository, and then the upstream is where you will make a pull request and say, hey, look, I've made these changes. I mean, in this case, it makes sense to think about a project like, I don't know, whatever. Let's say you're making an app, and or someone has an open source app, and you realize there's a bug in it. You fork that repository. So this is the apps repo. This is your forked repository. What am I doing? Let's do it like this. So we have the app repository, And then you have your one on your local machine and then GitHub. So let's say this is all in the cloud. And then you pull from your GitHub down to your local computer. And then you make the changes here. You push things back to your GitHub. And so this is the app that you realized there was a bug in on GitHub. And because you can't push directly to there, you say, all right, I've made all the changes and now I'm happy with it. I've tested it, the patch works, or my assignment is complete, or whatever the case may be. So what you do is make a pull request and say, hey, can you check out these changes I've made? And if they're good, bring them into your main app. Like, so there's always someone that reviews the code and says, hey, this is cool. There's no one's trying to put like a virus or something in there. And then they bring it, if they're happy with it and it's tested and everything, then they'll bring it into their main one. In this case, I'm just guessing, but the reason Lau has the pull request thing is just so he can see in a simple one, like a one place where the changes are. He won't merge all of our stuff into his one, but it's just the way you can see it. So I will run through that process now. Does that clear up the upstream thing? Because this essentially, in the workflow we're using, this is the upstream. So you don't work directly with that. Awesome. Okay, so I'll show this process now because it is something we've been doing. So let's say I want to create a new branch. I'll just say git checkout -b, which means create a new branch. And then I'll call it, all right, work in progress. Switch to a new branch whip. So any changes I make in here, like if I make a new file, okay, blah. Okay, so git status, we can see there's a new file. So git commit man new web. Did I do something wrong? Oh, okay, whatever. Git add web. So now we have that file in this thing, and I can push. So this is where it says, okay, you can push this, but there's no branch on GitHub called whip. So let's just make that using the command they tell us. It's pretty straightforward. It just says track this on GitHub with the same branch name. You could actually create a branch on your local one and call it something else on GitHub. I don't know why you'd want to do that. So it says, yep, new branch created on GitHub. So we can see here, whip had recent changes less than a minute ago. I can switch to that branch. So now I'm on the branch whip. There's a whip.txt. If I go back to the main branch, there's nothing there. So the reason I'm showing this is twofold. One is that the branch thing is a nice way to work when you're like just on modular stuff, like a particular portfolio assignment or one exercise or something like that, rather than having it all in a mess in the main thing. The other thing is I can easily demonstrate the pull request process with this same process, because you can pull requests from branches into the main, or you can pull requests from branches or your main into the upstream, in this case, Lau's repository. So I'm going to keep it as simple as that because we don't need to make changes in both branches or whatever. It handles it fine, so you don't need to worry about it. But let's say I want to bring the changes I've made. I finished my portfolio. I finished my exercise. I want to bring that back into my main branch or as a pull request into Lau's. We go compare and pull request. So in this case, you can say compare across forks. There is no other options here because nobody else has forked this repository. But if you do that, then you would also be able to see all of our forks of Lau's repository or his own. And then you can say, I want to merge into that one. But because we're not doing that, it'll just be my own repository, but from the branch whip into the main branch, which everything is kind of tracked on. So you can give it a title. You can say, finished portfolio, whatever. You can compare all the changes, see what's been happening. Doesn't matter. In this case, you just want to create the pull request. So wherever the pull request is done against, they will get a notification and they will be able to see it in this pull request tab on GitHub. So here you can see this is the pull request that I've just created from the branch, and it lists all of the changes in the commits. So here's new whip, and then you can see files changed if you want more detail about everything that's changed. So look, there's a new file here called whip, and it has the contents blah. And you can go do way more stuff than this, but for the purpose of this, I think that's enough. You've got the pull request, and the person who owns the repository, so because I own this, I'm allowed to merge it. If we're doing it against Laos branch or another app or whatever, you're not allowed to merge it. They need to review it and they choose whether they bring it into their code or not. So if I'm happy with these changes and I want to bring them back into my main branch, I'll just go merge pull request, and it's done. So you can optionally delete that branch. There's no harm in it because all the changes you've made and all the history is still there. But maybe you want to do further stuff on there. Yeah. So we have the GitHub methods 3 repository. You have your own on GitHub and whatever. So that would be the main one you'd want to use. And then you could make a branch per portfolio because eventually you bring that back into your main branch. But while you're working on it, it makes sense to have that because then so for example, the reason I say this is because for Laos repo, let's see. Yep. You can see the pull request we did for the practical exercises. I did this specifically from the prac2 branch. And that way, if I make more change, so normally if I did it from my main branch, everything I add afterwards will still get added to this pull request because it's like a work in progress kind of thing. So if you're happy and finished with it, or if you want to keep the changes separate, you can put in a branch. So I'm not going to delete this branch until Lyle said that's fine. I already merged it into our main, but until this project or this exercise is over, I won't delete that prac2 branch. But that means I don't make any more changes to that until it's approved, and then I delete it. But all the stuff is in the main branch, and then I will make the same if we have practical for next one, practical 3. Like I'll make a new branch for that and work on it in there. And that way you can just keep it separate. So now if I make changes to my main branch, it won't show up here and make it more messy, because then he would see like, oh, files changed, and then there'd be like not just the exercise, it would be like, you know, week 3, week 4, week 5, whatever. And so that's basically why you would do it. I would try not to think of it as a subfolder, but more, I guess branch is a good word for it, because it kind of, you split off and you can make more changes and then you can bring them back. I think it shouldn't be hard to find a graphic of Git branching. Let's see. Something like this. Whatever. Oh, sorry. Let's turn off dark reader. So you have your master. It used to be called master, and they changed it because of like the connotations of master and slave repositories, and you know that's fair enough. So now the main one is called main, which makes sense. But back in the day it was called master, and then you'd have like your various branches. This is a kind of typical like software development company workflow. Don't worry about this, but it's just to illustrate the branches. So you have your main branch, you make a branch for the project or the portfolio or practical or whatever, and then you make changes here, and when you're happy with them, you bring them back into the main branch. So this is, you can work on things in parallel. If you realize there was something wrong with the code, or you need to bring in changes from Lao's repository, they go into the main branch, and they can be brought into all the other branches if you want as well. But that's essentially what you're doing. You just create a separate timeline of code, and then at any point you can bring it back into the main with the pull request or using the commands, but I've shown you the pull request method because it's easier for now. The other thing was to, let's see. Okay, this is perfect, because There are changes, oh, actually no, there's not, but it doesn't matter. You can see here, there's an option to fetch upstream. So this will bring all of the changes from Lao's repository, because you can see forked from, and that's Lao's repository. So that means that that's kind of, for my forked repository here, the GitHub's methods 3, and probably for all of yours as well, that will have the upstream as Lao's repository. So if he makes changes, like let's say adds the exercises for, practical 3, and you want to bring them into yours without any hassle, you just come here and say click fetch upstream, and then you say fetch and merge. There's no changes, so it can't do that now, but you just say fetch and merge and it'll bring it into yours. So you'll have all the changes he's made in his without overriding anything you've done. And you can also do that for branches. And fetch upstream as well. Also, to make an easy way with pull request, you can just say open pull request here. And I'm not going to do it, but you'll see how it happens. So it's like, you can make a pull request, and it has all the changes that's been done in the repository. The only other useful thing in regards to this and branching is if you make changes in your main branch and then want to bring it into another branch, or vice versa. It doesn't really matter which direction it happens. So let's check out main. So now we're using the main branch. Let's see, I add a generic file that's nothing to do with like, a particular exercise, but poop. Oh, so generic changes. So I don't even need to put this to GitHub, but I will anyway because we're using GitHub as the main workflow. But so there's untracked changes. So I pull that, or not untracked changes. It's not changes that were on GitHub that were. Oh, fuck. Okay, so now I have all the so I got the whip one that was pulled into the main branch. We did the pull request. That's why it's there now. So that's perfect. That shows everything worked as expected. So I should be able to now push this back up, and we'll have this new poop file in only the main branch of our test repository. So main, there's a poop one. If you look here, it's not on the whip branch. So this says 3 commits behind main. That just tells you that there's changes in main that aren't here, which we know exactly. But you can probably do a pull request into a branch, I guess. But for here we'll do it via the terminal. So we'll just check out that branch again. So now you can see it tells you more or less what's going on if you do git status. It says we're on branch main, so you know where you are, and it says it's up to date with origin main. Origin main is GitHub, nothing to commit, so there's been no changes to the files. So we check out the whip branch. We don't need to do the -b now because the branch has already been created and it exists. So we just check out whip, git status, up to date, all good. But we know there's changes in the main branch. So another handy command is diff. So it just shows you what's changed between two things. So we can do git, diff, and main. And you can see here, it tells us that between the main branch and our whip branch, which we're on now, there's been a new file added, poop, with this content. And we're like, okay, we need to bring this into the other branch. So we can just say git merge main. It's that simple. Now it's brought the changes in. And if we do a list, we can see there is now a poop file in the branch. It's not on GitHub yet. But if we want it to be on GitHub, we can just do git push. And now it's there. So, I think that's basically it for the real quick tour of GitHub. And I did go a bit over time, so sorry about that. But I will stick around for a few minutes if there's anything in particular I wanted to ask, get clarification on. Yeah, so feel free. Oh, you're more than welcome. No problems. I'm happy to help. I understand it's a lot and it seems daunting, but hey, you guys are like all younger than I am, and I'm sure you'll have no trouble coming to grips with it. It's just learning new concepts and whatever, and hey, that's what cognitive science is all about. Just, expand your mind, man. But otherwise, yeah, I think it is a useful tool in general. And as I said before in the beginning, if you do anything related to coding, chances are you're going to be using these tools, and you'll benefit hugely from already knowing them, not going into a place that says, hey, make these changes, and you're like, oh, then how do I do this, and how do I add it to my repository and all that. They'll probably have everything already set up, so then it's just as easy as doing the commits and pushes and all that stuff. And let's see. Very welcome. Oh yeah, I will put this. I will publish this from Twitch to YouTube, so you will be able to like rewatch it or skip through to see if there was like a slide with some commands or whatever. I'll also put the slides somewhere. Where? Yeah, maybe I'll just put them in a Git repo, and then I'll put the link on the description in YouTube, and that'll be easiest. Alright, if there's nothing else, I'm gonna go because I have like a shit ton of reading, but I was having nightmares about Git last night. Can you believe it? So I thought I'd better get this over and done with. Otherwise, it's gonna fuck me up. So, yeah. I'll see you all at 2 o'clock.